Continuing the tour of the SMARTFIRE environment, we now consider the SMARTFIRE GUI or Case Specification Environment. This tool actually has two components. The first is a user interface in which you can enter 3D objects to create a scenario geometry, and it also contains a mesh generator for a structured mesh. The output from the structured mesh will be the command script file and the geometry file, which can then be taken forward to the CFD simulation. So to begin, we open the user interface for the case specification environment. I'm just going to change the background to white so it's easier to see in projection. On the left hand side are three panels. The view panel allows you to change view settings, although there is another way to change view settings by clicking and dragging to rotate, right clicking and dragging to pan, and middle mouse click and drag to zoom. The second panel on the left is the region tab. This allows you to set the size of the region using the values in the dimension boxes, and it also allows you to set the wall properties of selected surfaces of the region. The selection of the surface you want to edit can be achieved in two ways. First, by selecting on the unfolded box view to select a surface, or by selecting in the region display to select a surface directly. Obviously, in the region display, each selection could apply to one of two surfaces, so the selection will toggle through all of the available options. Once the surface has been selected, you can then edit the properties and examine and change how that surface will behave in the simulation. Usually, you will not need to change the settings, although in specific instances you may. The next panel on the left is the object panel. At present, there are no objects defined, so to start creating objects, you need to select New Object, which will bring up a panel which will allow you to select the type of object you want to add. The current list contains vents, which are openings in the outside of the structure, obstacles, which are solid materials which prevent flow, portals are objects which punch holes through obstacles, such as a door portal. Simple fire, multi-stage fire and simple heat are locations of fires with different properties to allow a heat release rate or fuel depending on the type of model being run. Burnable obstacle is a different type of fire where the surface is allowed to burn and flame spread is allowed to travel over the surface. An inlet is a momentum source defined by velocities. An outlet is an area where flow can leave the domain, as is a fixed pressure, although slightly differently defined by a pressure value instead. A thin plate is a thin obstruction that prevents flow. An aperture punches holes through thin plates to allow more complicated structures to be created. A fan and simple fan are momentum sources representing some sort of fan. A burnable plate is a thin surface which can burn and release heat or fuel. Monitor line allows you to create graphs. Monitor cells allows the CFD simulation to output data for specific cells in the simulation. The trigger cell is a tool to allow the activation, deactivation of specific geometry features based on values inside a cell. The trigger volume is similar, except that it allows a collection of cells to be averaged or maximum values to be taken within that region. A volume porosity allows partial volume flows to be defined. Face porosity defines partial blockages of areas, and a nozzle provides source of droplets for sprinklers or mist systems. Once an object has been selected, you can then add it to your domain, and depending on the type of object that's being added, you may need to move it around inside the domain, or it may be limited to the surfaces. If it's a 3D object, you need to position it and size it. That will become apparent as we actually set up an example case. For the moment, I'm now going to move on to the scenario problem type settings. This is probably the most important panel to consider in configuration of your simulation, because a lot of the objects that you add will have specific configurations depending on what modules have been activated. So it's worth first of all setting up the type of problem that you intend to model so that all of your objects will be consistent with the model options that you've selected. There is a wide range of different types of problems that you can run, and some of the information and some of the activations will be dependent on what you know about the simulation that you're about to run or configure. The choice between heat transfer and combustion model, for example, will depend on your knowledge about the fuel. Activation of the radiation model will be required if you have a lot of fuel that will burn or a high heat release rate, because radiative heat transfer will become a large mechanism of heat transfer when you have very high temperatures involved. So these sort of choices need to be made at the start so that all of the objects can be configured correctly. For the simulation that I'm about to run, I'm going to activate the radiation model. I'm going to leave the heat transfer model on. I'm not going to activate the combustion model. I'm going to deactivate the smoke model. I'm not interested in it for this particular simulation, as I'm not interested in toxicity products, and I'm not interested in this case in the sprinkler model. The other panels of the problem type configuration include solution control, which indicates whether or not the simulation is temporal or steady state, and also configuration of time step size and number of time steps. The convergence tolerance indicates how refined the solution must be before a time step can be finished. There are also some default physical properties for ambient temperatures, initial temperature in the domain, the material in the domain, and the default wall thickness. Once the problem type settings have been selected, you can then move forward to configure your simulation geometry. In this case, I'm going to create a simple two-room problem with an opening to the outside and a window. In order to do that, I'm going to set the region dimensions to 8 meters in the X direction, 6 meters in the Z direction, and 3 meters in the Y direction. So that's the outline extent of the domain that I'm going to simulate. Within this, I will create two rooms that are linked by a doorway, an external vent representing an external door, and also a window on the compartment that contains the fire. I don't need to change any of the settings about the surfaces. I'm happy with the solid wall, no heat conduction in this particular case. So I can now move on to adding objects to my domain. To do this, I go on to the Object tab and New Object. In the first instance, I'll create the external door, so I need the event. I add this, and I now select, using the unfolded box view, the surface that I want the vent to appear on. I'm going to put it on the high X surface over there. I now move and position my vent. I'm going to place it centrally and change its Y size to 2 meters. In order to create the partitioning between the two rooms, I could use two different types of objects. I could use an obstacle to make a thick wall, or a thin plate to make a thin wall. I'm going to choose to make a thick wall using an obstacle. I add that, and it arrives in the domain at the default position. I'm going to choose my wall to be at 5 meters and to be 0.1 meters thick. I then need to extend the sizes in the Y and Z directions so that it goes all the way up to the ceiling, and all the way across to the other side of the domain. I could have left a hole by using 3 separate panels to represent the wall, but it's often easier to create a hole through this wall using a new object, which is a portal. If I move this portal object so that it overlaps the wall, change its size and position, and width, so that I've created a doorway through the wall. I can now add a new object to represent the fire, which is a simple fire object, and I can again move this to a required position. I'm going to choose to be 2 meters into the room, 2 meters into the room in that direction, and change the size to 1 meter cube. I'm also going to set the properties for the fire to check how the fire will release heat. I click on the properties button, and here I see the menu to configure the simple fire properties. Because we're using heat release rate model, you see that the menu has a heat release tab. If we had activated smoke module as well, there would also be a smoke tab here. Because this is only a heat transfer problem, we have heat release in kilowatts that we have to define by some curve. And the default option is a 50 kilowatt fire that starts at time equals 0 in the simulation, and then continues for all of the simulation. I'm going to change the properties of the heat release curve to an expert curve, and now I have access to additional parameters in this expression, which I can change how the fire is defined. I'm going to increment the ends time to 200 seconds, and I'm going to change the C parameter so that I obtain a more interesting fire curve. And once I OK that option, that will be the definition that will be used in the CFD simulation. The last object that I'd like to create is another vent, and this will represent a window in the fire compartment, which I'm going to place on the high Z surface. I now need to position and size this to 1 meter in, 1 meter high, and with a width of 2 meters. At this stage, it would be perfectly possible to take this forward to meshing and to simulation, but it's often helpful to add some monitoring objects to allow you to examine particular data in the simulation. So I'm going to add a new object, which is a monitor line, and with the monitor line you have to define the direction, and I'd like to create a temperature stack in the internal door. So that's a Y direction monitor line. I want the x-axis of the plot to be temperature, the y-axis of the plot to be the y coordinate, and I select OK. I now need to move my monitor line object into the middle of the door. And move it across in the Z direction. It's worthwhile just visiting a couple of those options. So if we go to the scenario panel and pull down the menu, we see that there are configuration options for all of the different types of modules that can be activated, and also for the materials. And there are also configuration options for zones, optimizations, group solvers, meshing controls, and solver settings. Generally, with the majority of these, the default options are perfectly acceptable. Some of these will need to be changed. Module configuration, if you know more about the particular type of fuel or smoke, the defaults might not be appropriate. particularly important also for the toxicity and HCl model, where it's very dependent on the nature of the fuel and the nature of the combustion. So do take some time to consider the options available and what is appropriate for the particular simulation that you're about to run. The other important option for configuration is the output control. There's very little point in running a CFD simulation if you don't obtain any useful results. So opening the output control menu, we see the options that are available. There are options for restarts. This allows you to go back to saved instances in case the simulation goes numerically unstable and does not perform well and may need configuration changes to be able to complete. You see options for saving graphs and 2D visuals during the simulation. There are also options for saving the frequency of transient results and for exporting data such as the zonal export data that is needed for coupled SMARTFIRE and Exodus evacuation simulations. In the right-hand panel we see the list of output variables which can be saved based on the module activations. Whenever you change the module activations, this list will change and you need to select all of the options, all of the variables, field variables you actually want to save. In this case, I'm happy with all of the options that were set, so I don't need to change anything. Next thing that needs to occur is that the case needs to be saved into a working folder. So if I go to File, Save As, we see all of the cases that have been created in the SMARTFIRE work folder, and I add a new name which will be Test 2 in this case. And that saves the model for future editing and creates a folder for all of the results files which will be created, all of the input files which will be needed for the CFD simulation.